sometimes we run around the house in one sock.
And nothing else?
Nothing else. Well, I mean, he has on clothes, but on his feet, nothing else. Just, yeah, I know. I would not. That would feel weird to be.
You couldn't like slide.
Right. He will be running around the house with one sock on.
No, more like.
And sometimes they are outside like that. They wear their socks just like outside. Not barefoot and not with shoes on, just socks. I look him. Huh? Henry's 6, but Hunter's not a whole lot better, and he's 12, so I've made no progress. So, anyway, but you got me started on the socks. Now I'm going to have to calm down before we get started on the inverses. Okay. All right, so, okay. All right, inverses of logs and exponentials. All right, so we have already done inverses. So this is not really much new. It's just a different type of equation that we're doing inverses for. So when we did inverses, we did this. To find the inverse, we are going to switch the x and the y in the equation. We are going to solve for the new y. And then at the end, you can replace the y with f inverse of x if necessary for that problem. And then I added this step right here. We're going to use Desmos to check our answer to make sure that we did it right. Okay? Because the more we get to use Desmos on the exam, it is really helpful. The more we use Desmos for checking, the better you will be at it. And then sometimes they're going to give you an equation you can't do by hand, and you might be able to do it just with Desmos instead of having to know how to do it by hand. So, so it also, not only do I want you to be able to do it so you can know your answers right, this will help us when we get to that exam and they throw something crazy at us that either I didn't teach you how to do by hand, or it was so difficult that you've forgotten it already. Desmos can help you do that stuff. So I made like a flow chart here for what to do to check in Desmos, and we're going to use this as we go through. So you are going to graph. So up here at the top, it tells you what you're supposed to graph. You will graph f of x, its inverse, so whatever you have as the inverse. You might be using answer choices. You might have found it yourself and you're trying to check to see if you're right. And you're going to graph the line y equals x. And the reason we're graphing y equals x is because inverses are supposed to be, reflected over that line y equals x. And you're going to ask yourself the question, is the graph symmetric about y equals x? That means, could I fold it in half on that dotted line that I've got right there, and the two sides would match up? So, like, sometimes it's pretty easy to tell. Like right here, oh yeah, that looks like a line of symmetry right there. It's cutting that right in half. And so, yes, these would be inverses, if that's the case. Sometimes it's pretty obvious they are not symmetric. Like if I try to fold this in half on that dotted line, my two sides are not going to match up. So that would be an obvious no. Sometimes, I gave this example right here, you got crazy stuff going on. Like, I think that's probably symmetric, but there's really so much going on there, it's kind of hard for me to tell. So sometimes you may not know, and sometimes maybe something like this you don't know. So, to check further, if you switch the x and the y in your inverse equations, now both of the lines should look exactly the same. If they do, then they are inverses. If they do not, they are not inverses. Okay, so we'll walk through that with the first problem that we do. So let's go on. All right, this asks us to find the inverse of g of x equals 3 to the x plus 1. So for this, we got g of x equals 3 to the x plus 1. G of x is like our y right now, right? So what's our first step we do for inverses? Switch x and y. So we're going to put x right here, and we're going to put 3 to the y plus 1. And now we need to solve for that y right there. Which means we got to get rid of all the other stuff over here. Now the difference in solving equations and finding inverses is we're going to do everything the same, but our answer is going to be a new equation. It's not going to be a number like we've done. So I need to get that y by itself. I got a 3 over here. I got a 1 over here. Drew, what have I got to get rid of first?
The 1.
Okay, how do I do it? I'm going to subtract that 1. What is x minus 1? No, it's just x minus 1. We can't put those together, so we just write it as x minus 1. Okay, and so that's the difference. You know, yesterday we were doing equations. There was a number there. We got 7 or something. That won't happen here. You'll still have an x. All right, now I'm still trying to get that y right there by itself. How am I going to do that? I got to get rid of this 3. It's a base of an exponent, right? So to get rid of that 3, I'm not going to divide. Because this is not 3 times y, it's 3 to the y power. So to get rid of a base of an exponent, I've got to log it. Log base 3 is going to get rid of that. So if I do that, I've also got to log base 3 over here. And so now I have log base 3. Put some parentheses here around that x minus 1 because you're log base 3 in that whole side. And that'll give you y. You may not do the inverses, Jane. You may just rewrite, and that's fine too.
I just take the log. I don't take log base 3. You took base 3 because 3 is the base?
Yes, it cancels out that 3.
7 to the x or 7 to the y, you take log base 7.
Yep. Yeah, and it'll just cancel it out completely. So, g inverse of x, I'm just replacing that y, is going to be log base 3 of x minus 1. There. Yeah. Yeah. And so that would be our inverse. It's very similar to the equations we were solving yesterday. It's just we are going to have x's still left in our answer. Now, we can use Desmos to check this, and it's very helpful. So you guys can still see that slide over there that you guys can still see that slide. So to check on Desmos, it tells you there at the top, you need to graph the original function. So I'm going to call it g of x equals 3 to the x plus 1. So that's my original function. Okay. My inverse, instead of using that g inverse, Desmos does not like inverse notation. Just use the line before, use a y. Y equals log base 3 of x minus 1. Okay, go ahead and graph these on Desmos. I want everybody to try this. Okay, and then we're going to graph y equals x in the third line. So graph those 3 right there. And I like to go ahead and turn that green line, the y equals x, I like to turn it into a dotted line. That way I realize it's not real. It's just that's my line I'm trying to fold it in half on. So if you hit the gear right here, you can turn that to a dotted line by clicking. To do that, you just hit the gear, green, and you can change it to dotted if you want there. You don't have to. But, so I'm going to look and see if everybody looks like they got everything graphed right. If you want to change, I changed mine to dotted. If you hit that gear right there, click on the green dot. There's an option to make it dotted right there. I like to do that because it makes it where you can tell if there's both your graph. Check on your neighbor, see if you got it. I think most people do. Okay. Alright, now, does it look like we could fold this in half and the two sides would match up? Yeah, I think so. So I feel pretty good that I did this correctly, that that this is actually the inverse. Just to show you what it would look like if it was wrong, like let's say I had a plus right here. Does that look like I could fold it in half and they would match up? No, because that one is actually like over here, so that would be bad. But that's not what we had. We had this. Now, let's say you're still not sure. Let's say that your visual ability to fold something in half is not great. That you look at that and you're like, how do y'all know that looks like it's right? So let's say that this was confusing looking and we weren't sure. What is the first step we do when we find an inverse? We switch the x and the y. Okay? So if we have done it correctly, if we take either one of these, but I'm going to use the second one just because it's easier. If I turn this y to an x and this x to a y, it should match the other graph perfectly. They should be the same graphs. The red graph and the blue graph are now the same graph. So that lets me know, oh yeah, definitely these are inverses. Let me show you what that looks like if it's wrong. So like, let's go back. Let's say that was a plus. So let's say you thought you still weren't sure on this, that whether or not that folded in half. If this is wrong, I'm just showing you what it looked like if we had done it wrong. If I switch to an x here and a y here now, are my blue and red graphs the same? They are not. So that would let you know you've messed up somewhere and you need to go back and look at it. Okay? All right, questions on that?
So the ones on the side of the
Yeah, like like we had it at the beginning. Yes. So it should be passion where like if wait, let me fix it so it's right again. So it should be like if we could take this graph and fold it on that dotted line right there, that the two sides would match up. Sometimes they're complicated and that's hard to tell, but if a lot of times you can sort of tell that it looks right. Okay, let's go to the next couple problems. Actually, you try those two on your own. Let's see how we're doing. You can work with your partner if you want, but try those without me doing them. Right there. Because this doesn't have an X with it, it's just going to try it. Okay. You have a Y equals that. Yeah. So you put the original in and put your answer in, and you can leave that Y equals X there because it's the same problem. You can call it Y or you can call it D. Put this in. Yeah.
Yeah, I think I have the answer.
Okay. Put it in the Desmos and check. See if it looks right. Type it in Desmos. Okay. All right. So now we got to cut it up. So we'll get it. this log gets rid of that 4. So just leave it on, yeah. So like, we can make that. So like, check it, into first. Yeah, like, your answer into the second. And if you put in that Y intersection, the third line again, does it look like you folded it in half on a 3 line and they would match up? Yeah, I think so. So that just checks to make sure that if you got something that looks folded in half, then you probably how did I make it like that? I mean, when I make it dotted, it looks here, right here. You just because you did the 3. I just like that. It helps me too, so you know it's not part of it. It's part of the line. And you can just leave that, like, when you do the next problem, just leave that one there. And you stay there. This is supposed to be all right. So actually, we're writing here that one. That 5 right there is the text on it. So you actually have to model it. So it's not going to be on the side. So it's a little different. For which you're good here. That looks like you fold it in half. So pretty good. If you want to check for sure, what you got to do, change that to Y, and then change this to X. So it matches the other one exactly. That lets you know for sure it's correct. Yes. Okay. Alright, so we're going to switch our X and Y. So we'll have X equals Y. Instead of being like 4 times Y, it's going to be 4 Y powers. Okay, so we're trying to get that Y right there by itself. So
Well, I gotta do this. Wait, okay. Wait.
This Friday,
Is it an announcement? Okay.
check it, type in.
I know.
Type this.
What do you do?
Second line.
You are. Oh, I gotta cook. I'm gonna cook.
We had, yeah, so where we had the line right there.
Yeah.
Change that back to
Hey, where are the Are we on the right announcement?
click here.
Click here.
Please click here.
There you go.
Okay, it's looking pretty good on the first one. As I walk around and see.
Wait, how do we get there?
Okay, on that first one,
Oh, click here.
On that first one, you add the 2, you log both sides with a base 4, so you get y equals log base 4 of x plus 2. You can check it over here and plug it in. 4 plus 2 and log base 4 of x plus 2. What did I do? Oh, it's minus 2 right here. See how when I looked at that, I knew something was not right because it does not fold in half, right? So, what I did wrong, I actually didn't do anything wrong here. I typed the original equation in wrong. That was supposed to be a minus 2 right there. Now, it looks like you could fold that in half, right? Okay. On the second one, I'm seeing a lot of you that have y equals log. You may not want to write this down if this is not what you've got. Log base 3 of x plus 5. I was seeing that answer a lot. A lot of you got that. Okay, maybe don't write that down if that's not what you've got. Let's look at how checking this in Desmos can help us. Okay, so if I go back up here and for these two, I'm gonna do y equals 3 to the that 5 is in the exponent. To get it to stay in the exponent, you're going to have to type it in parentheses there. If you do a minus 5, it'll move it down to the bottom. If I do y equals log base 3 of x plus 5. Ooh, I'm not so sure about that one. Maybe, but I don't think so. They cross over here off of that. This is one of those that I would say, like, when I look at that, I don't think it folds in half, but I feel a little unsure. I feel a little, well, maybe, it kind of makes a symmetric pattern, but I don't think you can fold it in half. So if you're not sure, take one of them, switch your x and your y. Do those two match up perfectly? They do not. That tells us this answer is not right. So, if this is what you got, and I know some of you did because I walked around and saw it several times, this is not right. So, let's do this problem real quick. Alright, so you're going to switch x and y's. X equals 3 to the y minus 5. Okay, I think those of you that missed it, the first thing you did is you added 5. Why can we not add 5? It's part of the exponent. It's up here. That was not the case over here, right? So this is up here in the exponent, which means we got to get rid of 3 first before we can get to that 5. So how do we get rid of the 3? We're going to log 3 it. Can't divide because it's not 3 times y minus 5. It's 3 to the power. So we got to do log base 3, log base 3. So log base 3 of x equals y minus 5. Okay. Now we're trying to get rid of the 5. What can I do to get rid of the 5? I'm going to add that 5. But will it be like inside of the parentheses for this? I'm not adding it inside of the log. I'm just adding it over to the end. So log base 3 of x plus 5. If you want, you can put some parentheses right there. The 5 is not inside of the log. It does. Desmos puts the parentheses there whenever you type it in. So now let's try it. The original is the same. Let's try this answer. Y equals log base 3 of x plus 5. That looks much better, right? That looks like if I folded it in half, it would definitely work. And if I want to double check, if I switch x and y, they're the same line. So that tells me that this is the right answer. So that plus 5 is not on the inside of the parentheses on that one. Okay. Do you guys see the difference in that one? If you want to do it on the keyboard without having to go to the functions over here, whenever you want to do log and you want to base, if you do shift and the underscore key, it will take you down to the base there, and then you can put your 3, and then just go over and tell it of X there. So if you want to type it in without having to go to that function menu. Also, I saw some of you were not doing definitely I would tell you this, like if you want to do X to the 3rd power, if you do shift 6, which is the little caret key, it'll take you up to the exponent, so you don't have to go to the function menu every time for that also. So that saves you a little bit of time typing in. Yeah, this will also work right here. So you can do either one for that. But that's not what we need here. Okay. All right, so let's continue on. We need to do one that's a log, because those are all exponentials we've done so far. All right, so it's not much different. Since this has a log with it, what do you think we're going to have to do to find the inverse? Drop the logs is when they're on both sides. The inverse of a log is going to be exponents, right? Exponentials. So we're going to switch x and y's. So x equals log base 5 of y plus 2. And if they do not put parentheses, then you are assuming that that just goes here. The x plus 2, that 2 is not in the parentheses. If they want that plus 2 to be in the parentheses, they will put parentheses around it. Okay, so, and it may be helpful even to kind of like put those parentheses there so we know. So this 2 over here, can we get rid of it? Yes, we can get rid of it because it's not inside of the log. We're just going to subtract 2, subtract 2. So x minus 2 is going to equal log base 5 of y. Okay, Easton, what do I do to get rid of that log base 5? What do you think, Andrea? 5 to the power, right? We got to do 5 raised to that power. Because bases of logs and bases of exponentials, they are going to cancel each other out. If you do 5 to the log base 5, it just cancels. And so we do 5 to the power over here. And so we have 5 to the x minus 2. That whole thing is in the exponent equals y. You may even want to put some parentheses around that to remember the whole thing is the exponent. Because when you type it in Desmos, you're going to need the... So if we check to see if we've done it right, y equals log base 5 of x plus 2. And then we do y equals 5 to the x minus 2. And I don't like that it made that the same color. Let me change that. So, drag this back over here. Does that look right? Does it look like we could fold it in half? Yeah. So, I think that looks pretty good for that. If I want to check, I can switch x and y. Switch a x and a y. Oops. And they become the same, so that looks good there. Okay, 5 is going to be a little bit different. No, 5's not a lot. Well, it's different, but not terribly different. First of all, it might kind of mess us up that we have natural log, because natural log does not have a base written. What is the base for a natural log? It's an e. So if you want, you don't have to do this, but you can write this as 3 log with a base of e of x if you want. It's not necessary, but you can. So if I'm, oh wait, let me go ahead and switch my x and y. So while I'm doing that, let's make this an x, let's make this a y. X, y. So I'm trying to get to this y right here. What have I got to get rid of first? whatever's furthest away from it, which is my 3. How do I get rid of that 3? We got to divide, because it's right beside that log, so right now it's being multiplied. To undo multiplication, we divide. So we're going to divide both sides by 3. X divided by 3, we can't do. We just write it as x divided by 3. Most of the time, whatever's over here with that x, you're just rewriting it. You're not actually adding, subtracting, multiplying, dividing anything. We got log base e of y, or you can call it ln if you prefer. Okay, so I've got a log with a base e. How do I get rid of a log with a base e? We're going to do e to the power. We'll get rid of this over here. And so we got to do e to the power over here also. So this is e to the x divided by 3 power is going to equal y. So if I check that over here, we would type in our first y equals 3 ln of x, and then we would type in y equals e to the, you're definitely going to need some parentheses here, x divided by 3. And does that look symmetric? Does it look like we could fold it in half on that dotted line? Looks pretty good. So we would say that's correct. Okay, questions there? We just got one more slide left, or are there 2? 2. Okay. All right, go ahead. I want you to do those. Do the last 4. See what you can get on those last 4. Okay. Check them on Desmos as you go. And I'm gonna have. Oh my God. Mm-hmm. Let's see. Yes, I'll fix that. That'll be perfect. Yeah. That'll be actually perfect, won't it? Let's hope it stays. Uh-oh. Okay, that'll be fine. We can handle that. But if it turns to rain, yeah. If it turns to rain, we're going to have a problem. I don't know what we'll do. Because most of that stuff is not going to be the same if it is. Yeah. 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 Yeah, they